Hi, my name is Dave, and today on Gear Up with Greggs, we're going to be talking about hydraulic systems, more specifically the inner workings of a hydraulic system and the products that Anchor Fluid Power manufactures that makes these systems as efficient as possible. Hydraulic systems are all around you, and you may not even realize it. For instance, the power steering in your car, the forklift whizzing by you at work, and the large backhoe ripping up that road right in front of your house, they're all run with the assistance of a hydraulic system. Now this is great and all, but you may be wondering how a tiny pump is going to create enough force to lift a 1,000-pound object. Well, this happens through the hydraulic transfer of power. If you look at this graphic, piston B is 10 times the size of piston A. But through the transfer of force, you could put 100 pounds into piston A, and piston B will lift 10 times that amount, or 1,000 pounds, 1/10 of the distance. So, using hydraulics to lift the heavy weight, you need to exert less force but over a larger distance. For the rest of this video, we will be using this graphic of a hydraulic system to show where Anchor Fluid Power's connections come into play. The hydraulic system is made up of 5 basic components, the first being the reservoir. This contains the fluid used in the system, which is most often hydraulic fluid. Next, we have the pump. This takes the hydraulic fluid from the reservoir and pressurizes it, sending it into the control valve. The control valve then controls the direction of fluid, sending it either to the cylinder and extending it, or sending it back to the reservoir. The cylinder is the slave of the system. It extends or contracts depending on what side of the piston the pressure is applied to. Lastly is the plumbing. These are the components that are used to join the reservoir, pump, control valve, and cylinder all together so the hydraulic system operates properly. In a hydraulic system, valves are needed to regulate the fluid more than a simple on and off switch could. This is where Anchor Fluid Power valves come into play. The first valve I'm going to show you is a check valve. This valve would connect to the plumbing between the pump and the cylinder. Its primary function is to only allow the hydraulic fluid to flow in one direction. If you look at the cutaway of the valve, you can see that the inside of the valve features a metal ball and a spring. When the pump is turned on, the system starts to apply pressure to the metal ball, which eventually pushes back on the spring and opens up the valve. This valve is a one-way design, which means fluid can only flow in one direction. When the pressure on the ball subsides, it returns back to its resting place, sealing the valve once again. Here at Greggs, we carry either a 7 psi or a 65 psi valve. PSI being the amount of pressure needed to open the valve. Next up, we have the needle valve. Just like the check valve, this one sits in the system, but rather than restricting the flow of fluid in the system to one direction, this valve's primary function is to limit the flow of fluid coming from either direction. As you can see in this cross-section, a needle valve uses a tapered pin to gradually open a space for fine control of the flow rate. The flow can be controlled and regulated with the use of a spindle. It would be comparable to building a dam in a river. You see, a small dam would not stop the flow of water, but it would limit the amount that gets through and slow down the stream. When the knob is screwed down into the valve, it limits the amount of fluid that gets through. This is helpful when you have a cylinder that you want to raise gradually. If you had an unrestricted flow fill up the cylinder, it would extend or shoot your object up at an uncontrollable rate, compared to if you had limited the amount of fluid going through. The major difference between the needle valve compared to the check valve is that it restricts the flow in both directions. Our next valve is the flow control valve, and that's this one right here. It combines the properties of both the check valve and the needle valve. As you can see in this cross-section, When fluid runs through the valve, it initially has to run into the needle valve where its flow is limited, allowing it to fill up the cylinder in a controlled manner. When the cylinder is then lowered, rather than the fluid being limited in its flow, when enough pressure is built up, the fluid pushes on the ball, which allows the fluid to move freely and unrestricted back into the reservoir. Now you may be wondering which of these valves would be best for your specific application, and unfortunately we really can't tell you that. Hydraulic systems are very application specific, as the amount of pressure flowing through them can vary. It is important to consult a hydraulic engineer to ensure you are buying the correct components for your system so you do not experience poor performance. When picking out valves here at Gregg's, you're likely to start by looking through our catalog, where you may notice some symbols associated with the valves. These are the symbols that would be featured on an engineer's schematics or blueprints of a system. These symbols are also stamped onto the sides of the fittings for identification purposes. Here you see the symbol for a check valve. The circle symbolizes the ball and the zigzag symbolizes the spring in that specific valve. The orientation of the ball and the zigzag also tell you the direction the fluid would be flowing through the valve. On the needle valve drawing, the U shapes symbolize the valve and the arrow symbolizes the needle. Please note that the arrow means it's adjustable, and if it were to be just a slash, it means it is not adjustable. Although there is proper direction of fluid through the valve, commonly denoted by either a flow arrow on the diagram itself or by numbers stamped onto the fitting. For example, the flow on this valve would be running from point 1 to point 2. The final symbol is the flow control valve symbol. As you can see, both the check and the needle valve symbols are combined in it, but they appear on different lines, which shows the flow directions. Anchor Fluid Power also manufactures a number of hydraulic ball valves, which are right over here. When it comes to ball valves, here at Gregg's we carry two types, the two-way and the three-way. Here we can see a two-way ball valve. As you can see, there are only two ports. Having only two ports means that you can either open this valve and have your fluid run through it, or you can completely seal it off and block the flow. You would use this type of valve on either end of the components in your hydraulic system so that if a problem arises in your pump, for example, you can cut off the flow to this area and replace it without having to take apart your whole system. Basically, a two-way ball valve makes maintaining and repairing individual aspects of your system much easier. Here is the three-way ball valve that is offered by Anchor Fluid Power. This valve features 3 ports as seen here. Rather than completely stopping the flow of a system, the three-way port can divert the flow of the fluid, for example, to another cylinder when maintenance is required. This allows you to bypass the cylinder rather than shutting down the entire system. Here at Gregg's, we sell 2 versions of this valve, the AE3 and the AE3K. The difference between the two is that the AE3K is considered a true three-way ball valve, meaning any port on it may be pressurized, and when it is sealed off, it is able to withstand the pressure of the fluid pushing on its sealed ports. As opposed to the AE3 series, which can only be pressurized in the center port. We also carry both a 2- and a 3-way ball valve in an excavator style. The main difference being that an excavator style ball valve is specifically made for, you guessed it, excavators. You can weld this valve on and it can withstand temperatures up to 145 degrees Celsius, which is really critical as this machine could be used for hours at a time, creating a lot of heat within the system. These valves are also handleless, as the handle can become a liability out in the field if it were to be bumped or moved by an uninformed employee or other machinery. Well, that's all for today, and I want to thank you for watching Gear Up with Gregg, and I hope you learned something new about hydraulic systems and these application-specific valves offered by Anchor Fluid Power. Remember to always consult an engineer when looking to replace or add a valve to your hydraulic system, as these contain high pressurized fluid and safety should be your #1 priority. If you have any other questions or want to get a closer look at the products we carry, feel free to visit our website at greggdistributors.ca. You can also stop by one of our many Western Canadian locations and grab a complimentary coffee while you speak to one of our friendly counter staff. And remember to have a great Canadian day.